differentiation. How do we take derivatives when we have implicitly solved equations? We love when things are in explicit form. Explicit form, if you recall, is when it's y equals everything else. Very easy to take the derivative because we're taking with respect to x, you take the derivative of everything there. When x's and y's are mixed up, like that, one option is to solve for y. I don't know about you, but that does not look like a nicely, easy to solve equation for y. Okay, so we have to have a plan B. And our plan B is called implicit differentiation. Okay, so we've been able to differentiate functions that are solved for y explicitly up to this point. Now we want to consider functions like this. It would be challenging to solve for y. Some facts to consider. Realize differentiation is taking place with respect to x still. So, and I'll talk about what that means when we go through that. When you differentiate terms involving x alone, you can differentiate as usual. Okay? When you differentiate terms involving y, you must apply a chain rule. And this is because y is defined implicitly as a differentiable function of x. It all has to do with because we're differentiating, taking the derivative, with respect to x.
What does implicitly mean? Like
it's not
like
this is implicitly. It's not, so explicitly is y equals x squared minus 4x plus 3 because it's y equals. Implicitly, everything is together. Does that make sense?
Yes.
So this is like an explicit one. Although I don't know that I want to leave that right there because that almost looks like that's what it's supposed to be solved as, and it's not, but that's the difference. Okay, and then, so kind of the idea here, when we're within things. I'm going to look at the bottom one first. The derivative, this is saying what is d dx of x. What is the derivative of x, or the derivative of x with respect to x? So what's the derivative of x? That is just 1. Now, this is saying what is the derivative of y, but with respect to x? Well, okay, first of all, what is the derivative of y? It is also 1, but with respect to x, we then say times dy dx. So this is really like saying it is 1 times dy dx. You just don't need the 1. So every time we take a derivative with y's involved, we take the derivative, and then if it was a y term, you tack on a times dy dx. Okay? Now, as we look at these examples, we have some guidelines. Differentiate both sides with respect to x. Obey the chain rule by multiplying by dy dx every time you differentiate an expression containing y. Isolate dy dx by getting all the dy dx on one side, everything else on the other side. Factor out a dy dx and solve for dy dx. Okay, I know, makes no sense right now. Let's look at example 1. Asking us to find dy dx, so asking us to find the derivative for xy plus y equals 8 and at 3.2. Or at 3, 2. 3.2? No, because we need to find the derivative. We're not just finding the equation. We have to find the derivative first and then plug in 3, 2. So, right off the gate, how do we take the derivative of xy? No, not yet. We have to take the derivative first.
1 times 1.
Product rule. Product rule?
Oh.
I know, right off the gate, we're jumping in. Okay, so derivative of xy is a product rule because it's x times y, yes? So what is the derivative of x? Derivative of x is 1 times, and then you're going to keep the y, plus. Now we're going to keep the x. What is the derivative of y?
1.
And it is 1 times dy dx because we just took the derivative of a y term. Now, do I have to write that 1 in there? No, but we're beginners here, right? So that's the derivative of xy plus What's the derivative of y? It's 1 and then times dy dx. And I get it. Do we have to say the one? No. I just am for this example. Equals, what's the derivative of 8? 0. Okay. Let's do some cleanup. 1 times y is y. X times 1 times dy dx is x dy dx. And 1 times dy dx is just dy dx equals 0. Could you have just gone straight to this step right here? Yes, as you get better at this, you can. I just didn't dare do that on step 1. Okay? Now, so that is step 1. Differentiate both sides with respect to x. Isolate dy dx by getting all the dy dx terms onto one side, everybody else on the other side. What's that mean here? Subtract what? Subtract y. So I'm going to keep x dy dx plus, I'm going to keep dy dx equals, I'm going to subtract the y over, 0 minus y is negative y. That's step 2. Step 3, factor out dy dx if necessary. And honestly, you can combine steps 2 and 3 once you get better at it. Okay? But both terms have a dy dx, yes? So I can factor out dy dx as a GCF. What's left in parentheses? X plus invisible 1 equals negative y. Step 4, solve for dy dx. This is dy dx times something. So how do you solve for dy dx? You divide by something. So I'm going to divide by the quantity x plus 1. And when I divide by x plus 1, it's going to drop out on the left. And on the right, I'm going to have negative y divided by x plus 1.
Now you
Okay.
plug it in.
Now we can plug it in.
Kind of was ready.
Everyone's been ready for it. They're like, plug it in, plug it in. So now, and I'm going to write this as dy dx. I'm going to use, it's called an evaluation bar, evaluated at 3, 2. Just fancy notation. This is saying the derivative evaluated at 3, 2. So
Negative 1.
I agree.
Yes.
You should eventually get to negative 1/2. If you don't, ask, check my work against your work, see where you made your mistake. Good?
Okay.
Okay. Let's try example 2. Differentiate x plus 3xy minus 2y squared equals 2 at 1, 1. Leave the watch alone.
Sorry.
That's a phone.
I know.
You're not on it. Okay. Derivative of x. 1. Plus derivative of 3xy. Product rule. And my suggestion when it's 3xy is just keep the 3 with one or the other. That's what I tend to do.
That's what I was just going to ask you with these 3.
Or it's basically 3 times the product rule of xy. But I just tend to, in my brain, I think, okay, I'm doing the derivative of 3x and y. Those are the pieces I'm doing here.
Okay.
So
It's you keep it with one of them.
it doesn't go with both. It can go with one or the other, or, this is not what I'm going to do, but you could say 3 and then do the product rule of xy.
Okay.
Does that make sense? You can do 3 times the product rule of xy, or what I tend to do is I just say, okay, what's the derivative of 3x? 3. Keeping the y plus, now this time I'm going to keep the
3x.
3x.
That's what I was wondering about. If you kept
What's the derivative of y? Now, are you guys okay if I just not put the 1
Yes.
and just put dy dx? If it's something other than 1, obviously you have to put it, right? Minus. What's the derivative of 2y squared? 4y times dy dx equals derivative of 2?
0.
0.
multiplied it by dy dx.
Because anytime you take the derivative of a y term, you multiply by dy dx. Are we forgetting that already? Is that the frustration?
No, I just.
Okay.
I
I'm
thought
gonna.
that had to do with chain rule.
Yeah.
But I don't think it was.
Let's see. We can get fancy and do a lot of this all at once, but I'm afraid to do that. How about, can we keep the x, can we go ahead and kind of clean it up, but keep the xy terms and move everybody else?
Sure.
As in, what am I keeping here then? The 3x dy dx minus 4y dy dx is going to equal what?
Negative 3y minus 1.
And maybe I shouldn't have done that. Because what are my terms here? We have
I was trying
1,
to figure out where you were from.
and what's 3 times y? That is 3y, right? So I move basically the 1 and the 3y over. So that's isolating dy dx. Then factor it out. This is where I'm saying some of you would have factored it out on the last step too. Whoops. Dy dx factored out. What remains in the parentheses? 3x minus 4y equals negative 3y minus 1, or negative 1 minus 3y if that's your preference. And now we can divide. Dy dx is negative 3y minus 1 over 3x minus 4y. It's not pretty, and that's okay. And now we're going to evaluate dy dx at 1, 1. And I matched my own answer key. Did you not like me doing that on my own?
No.
I'm sorry.
No. What
Usually you guys complain.
did I get? How did
I don't know.
Oh, that's what I.
You guys all complain if we, a lot of you complain if we do it out loud. Like, hey, wait, don't say this yet. Don't say this yet. So it's just plugging in numbers. I can do that. Let you guys meet up with me.
Okay, there we go.
And by all means, if you're not meeting up with me, talk to me. Right? Tell me what I need to explain differently.
That was all about if I got a negative in there.
Negative 3 times 1 is negative 3, minus 1 is negative 4. 3 times 1 is 3, minus 4 times 1, so 3 minus 4, negative 1. Negative 4 divided by negative 1 is 4. Okay, we get to practice a couple more times, don't we? Oh, we get some fun ones on this side, don't worry.
Yeah, ones that say cosine and sine and y
Okay.
to the x.
Moving on. Example 3.
Oh, crap.
Yeah, that's what it looks like.
3.
Okay, well, example 3, we're still staying normal-ish. Derivative of y cubed.
3 3y.
3y squared. So the derivative of something to the third is 3y squared. Then it's doing the derivative of y, which the derivative of y is that dy dx. That's what you're really thinking. plus derivative of 5y squared,
10y.
10y dy.
10y dy dx, minus the derivative of 5y,
5 dy dx.
5 dy dx,
Oh.
minus the derivative of x squared
2x. Equals 0.
equals the derivative of negative 4, 0. If you're fancy enough, we could factor the dy dx term
And move the term.
and move the 2x. Are we crazy enough to do that, or are we not there
Yes.
yet?
Yes. Let's do it.
What about those of you not talking to me?
We are psychotic.
It's just, you gotta give me a minute to look at it.
Sophie.
At this point, I'm just like, alright.
I want to do it if I should.
dy
That's what-
dx, and then in parentheses 3y
3y squared
plus 10y minus 5 equals 2x.
Okay, you did that fine.
You've got it.
That one.
Okay, so we've got 3 dy dx terms. We factored out dy dx, leaving us with 3y squared plus 10y minus 5 in the parentheses. There's that minus 2x that I haven't touched yet that needs to go out.
I mean, if you want to get.
So we're going to add 2x and right there. Want to get crazy, we could go straight to the final answer. I'd rather we show a little bit of work. Okay? And here's what I'm always going to tell you guys. It's really hard to do partial credit if you just jump to an answer. Okay? And some of you want to do that to me. Just makes it difficult. So, dy dx is equal to
2x
So-
3y squared plus 10y.
And?
Evaluate.
No, even.
Except we're not evaluating this time. They didn't give us anything to evaluate with.
Nice.
We're done. We get to leave it as that mess.
That's why I was confused. I'm like, wait a second.
I want to go farther. I can't go farther. Okay. Now, 4 says find y prime.
Same thing.
Y prime
It's just.
is another form of dy dx, right? We understand that. Y prime is just another way to say dy dx. Now, I can demonstrate here, but what I'm going to tell you, because you technically, instead of using dy dx's, you could use a y prime every time. But y primes and y's, you overlook a prime mark.
Here comes the sliding llama again.
How'd you guess? The thing is, I don't even know if I would have noticed, but it's Mario's reaction that it gets me every time. Okay, so you could, instead of like every place here we put dy dx, you can put a y prime. But the problem with putting a y prime is you overlook the prime that looks like a y. It just, it's kind of difficult to do there. So, okay, derivative of y to the x.
Really,
actually drive me crazy.
Y to the x.
That's part
1
Oh, it is practical.
parentheses.
Product rule? Because it's y times e to the x.
Yeah. But it's,
So,
oh, it's e to the x. I put y and e together.
Oh.
And then the x is the exponent. So would it be like x, y? That's what I was
Okay, so-
doing.
what's the derivative of y?
dy dx.
So 1 dy dx, right?
Oh,
Times e to the x.
I forgot the entire premise.
Times e to the x. So, okay, first half. Derivative of e of y is just 1 and then dy dx, keeping e to the x. Plus-
e to the x.
Now this time I'm going to keep y. What's the derivative of e to the x?
E to the x.
E to the x. Equals
0.
the derivative of 3 pi?
0.
0, because 3 pi is a
Constant.
number, constant. Okay,
6.1415.
See, now I don't know what to do for you.
Yeah, same.
6.28 something.
What?
Okay. So step 1, dy dx terms on one side. So dy dx, e to the x, I'm going to keep on the left. I'm going to move anything that doesn't have dy dx, so I'm going to subtract y e to the x. Notice that next step that said factor, it said factor dy dx if necessary.
This is not necessary.
It's not necessary because there's just one term.
You can leave it
So-
like that.
No, we got one more step. If it's dy dx times e to the x, how do you get dy dx by itself?
By
Or divide.
It's going to be dy dx equals negative y
Can cancel.
e to the x divided by e to the x,
Negative y.
which does become negative y.
well,
Now, if you looked in her answer key at this problem, at this point, it probably says y prime equals negative y.
No.
I don't know. I stray away from using y primes. Okay. You ready for 5?
No.
Yes.
Yes.
Let's do it.
There we go.
No.
I got my cheerleader in here.
Oh, we get to use the chain rule here.
Okay. Differentiating cosine of xy equals x plus 3y. What is the derivative of cosine of xy?
Negative
Negative
sine.
sign.
Okay, derivative of cosine of something is negative sine of something
Product rule. Times the derivative.
times the derivative of
The inside.
the inside. So cosine is outside. We did the derivative of cosine to negative sine times the derivative of the inside. So now we're doing the derivative of xy. But xy is a product. Okay.
Sorry.
It's a product, yes. So the derivative, and I'm going to put a big old parentheses here. The derivative of x is 1
Oh.
times y
Plus
plus,
x dy dx.
now I'm going to keep the x, and the derivative of y is 1, and then times the dx, dy dx. Oof. Equals
Oh my god.
the derivative of x
One.
plus derivative of 3y.
3 dy dx.
Are we okay with that?
Yes.
Divided by negative sine xy.
Underline it, because that's all we can do. Hooray!
Okay. So officially, our job is to get all of the dy dx terms to one side, correct? Now, and this is where I was pausing because I had to gather my thoughts. I assumed that I should. Yes. Okay.
The y.
Now, I can't subtract a y because y is in parentheses.
So y plus e. X dy
Where?
dx.
E. Where are you pulling the E from?
E. I didn't mean e.
You can't subtract it though, it's multiplying.
Okay, here's the deal. Whatever is inside this parenthesis, the only thing I can do with this parenthesis is to divide it by the other side. And that doesn't help.
Oh, okay.
That doesn't help, okay? Because then I have dy dx's on top and bottom, but I also have non-dy dx's top and bottom.
Teeny.
We.
Problem solved.
Give me the sign. Oh, never mind.
Ah!
Because in my parentheses, one term has a dy dx and the other does not, we need to distribute. So,
Not if I have parentheses.
negative sine xy times 1y.
Negative y sine xy.
So it's 1y, which is just y. When I multiply y times negative sine xy, I don't like to put something after my sign. Because then you run into that trap of, is it part of the sign, is it not part of the sign? So I prefer to put most things in front. And so negative times positive is negative. Negative y sine xy is my first distributive. Then it's going to be minus times plus, so minus sine xy times x times dy dx.
Minus x sine
I keep saying
D
y
Y.
dx.
I don't know why I keep saying e.
You're like,
I don't know.
Okay, so sine xy times x is going to be best written as x sine xy, and then I'm just going to tack on the dy dx afterwards. I know, I just said I don't like putting things afterwards, but dy dx is a little different. Okay? And then the 1 plus 3 dy dx is just hanging out. Not yet. I'm still working on, I don't know, is it step 1, step 2, whatever, where I need all my dy dx terms on one side, non-dy dx terms on the other side.
In my brain, I thought you were. Can you add x sine x1 dy dx and then subtract the 1?
Okay.
You could. I mean, either way, we're going to have a couple of negatives is what's going to end up happening. I totally get, which way did I do it here? Well, it doesn't matter. And I can talk about equivalent answers in the end here. So you guys are suggesting adding the x sine xy dy dx to the right?
Yeah, that's what I just.
And then if we're doing that, we're going to subtract the 1 to the left. Okay, so let me write this out. Negative y sine xy stays. And then we're subtracting 1 from that, yes?
Mm-hmm.
On the right, I'm going to actually put the plus x sine xy dy dx term, and then the plus 3 dy dx. Not that the order matters. It does not. You just need both terms over there. Okay, I have dy dx is on one side, non-dy dx is on the other side. Now we're ready to factor out the dy dx. So, and again, I know some of you can see stuff and you can start doing multiple steps. Just make sure some steps are shown. I'm showing everything. When I factor out my dy dx in my parentheses, x sine xy
Oh, did I forget that?
plus 3.
XY. Oh my god.
Now we're ready to
Divide.
divide. On top is the 1 with the y sine xy and the 1. Mine are both minuses. So negative y sine xy minus 1 divided by x sine xy plus 3. Right?
Right.
What? Yeah.
Now, my answer key reads differently. My answer key has both terms on top being positive and both terms on bottom being negative. That's equivalent though. Because if I can multiply my fraction by negative on top and negative on bottom, I'm multiplying by a positive 1, it's equivalent. Okay, so if every sign top and bottom are just the opposite sign, you are good there. And that just has to do with, in my notes, I moved my dy dx's left instead of right.
That's
Okay? And it doesn't matter. Okay, it's equivalent. Any math teacher is going to know that it's equivalent. Okay? Let me rephrase that. Any math teacher teaching upper level math is going to know it's equivalent.
And he's smart.
You know, I can't guarantee, I don't know, elementary. Yeah, I know. I'm like,
Kindergarten.
I would like to think I could guarantee middle school, you know, but I would definitely not guarantee elementary, so. Okay. Let's look at 6. Differentiate. Natural log of xy equals sine x.
Can we split into natural log x, natural log y?
You can. Now what I'm trying to decide here is which option is the better.
Is that the favorite?
I mean, okay. So I'm going to say or here. And the idea of, okay, this is a log rule. Two pieces this is what would be called the product rule. 2 pieces multiplied inside the log are equivalent to
To be added.
natural log of x plus natural log of y equals sine x. Guys, they're both going to end up with the same answers eventually. That's what it comes down to. Okay? So here you're either doing the derivatives individually, and it's just different solving. Yeah. Or here you're doing a product rule inside of a chain rule. I don't know. Which way do you guys want me to go?
Let's go to Shane.
You want to do that one? Doesn't matter to me. So, okay, if we do this one, what's the derivative of natural log of something?
1 over
1/xy.
1 over xy times, I'm using parentheses, what's the derivative of xy?
1
dy dx.
Wait, what? No.
No. Derivative of
Oh,
xy. We did the derivative of both, and I followed whoever said it.
1.
1.
Derivative of x is 1, keep the y. So 1y plus derivative, now we keep the x, and the derivative of y is dy dx. My apologies.
I thought I was getting this right.
I fell into the trap, okay? We all follow each other.
A little bit.
Okay, derivative of sine x is cosine x. Woo. Okay. Probably your best option is to distribute. 1 over xy times y.
Y over xy. X.
Y over xy, which becomes
My bad.
1 over x. Plus x times 1 over xy times dy dx.
Lost me there.
1 over y
Yes,
dy
I
dx.
And I guess what, okay guys, do we need the 1 over xy times y? Y's cancel, there's my 1 over x, right? Same type thing happened on the next one. Equals
Cosine x.
cosine x. If you had done this one, taken this first step, you would be at the same second step. Okay? So if you went this way, you're at my same next step. I want dy dx by itself, so I'm going to keep 1 over y dy dx. I'm going to keep cosine x of where it is and subtract 1 over x. Best way to get rid of 1 over y. Multiply by the reciprocal. What's the reciprocal of 1 over y? Y. What you will likely see written is y times parentheses cosine x minus 1 over x. You probably won't necessarily see it distributed. Okay? Okay. Tomorrow, we will come back and talk about 7, 8, 9. And you will get some work time,
7, 8, 9, then homework time.
and then homework time. She's a poet and didn't know it.
Whoa.
Some of the homework problems are bigger, though.
They are pretty big.
The homework problems are bigger.